In this video, we're going to continue to talk subscriptions, and we're actually going to expand on the comment and post subscriptions that we already have. So let's take a quick moment to talk about the three main ways we can mutate data. Data can be created, data can be updated, and data can be deleted. We want to notify subscribers in the case of all three. Currently, both comment and post only notify subscribers in the case of that first one, when data is created. So if I were to subscribe to all comments for post 11, I am indeed going to get all new comments for post 11. The problem though is that if a comment gets updated or a comment gets deleted altogether, the client does not get notified about those changes, and that kind of defeats the purpose of subscriptions. The whole point of being able to subscribe to data is to keep the client and the server in sync. So when a new comment comes in, I want to show that to the screen. But when a comment gets edited or deleted, I also want to update the UI to reflect that as well. So all we need to do is make some changes to how we're structuring our type definitions for both of our subscriptions. Then we're going to add some additional pub/sub calls into the mix. In this video, we'll be working on the post subscription together, and in the next video as a challenge, you'll be working on expanding the comment subscription. Now, one change we're going to need to make before we add more pub/sub.publish calls has to do with the data that's getting sent back when someone subscribes. If you subscribe to comment, what you get back is a comment. If you subscribe to post, what you get back is a post. So for example, we have our comment subscription over here, and if I scroll up, we can see the exact data we got back just a couple of videos ago. We have an object with the data property, then we have the comment property, then we have all of the data we actually requested about that newly created comment. Imagine if we continued to publish in this fashion for when a comment was updated or when a comment was deleted. It would not be clear exactly why I'm getting this comment back. Am I getting this comment back because it's a new comment and I should be showing it to the UI? Am I getting this comment back because it's updated and I should replace the text with the new text? Or am I getting this comment back because this comment has actually been deleted, in which case I should remove it from the user interface? It's not clear to the subscriber, the client, why exactly this data is coming back to it. So all we're going to do is include alongside of this data a simple string field. The field name is going to be mutation, and it is going to store one of three values, either the string created, the string updated, or the string deleted. That's going to give the subscriber enough context to figure out what it should do. Now to knock that out, all we're going to do is change the value that comes back from both of these subscriptions. We're going to start together with post. What we're going to do is return a different object. It is still going to contain the post data, but it's also going to contain one additional field. We're actually going to create a brand new type def for this, so let's add that down below. At the very bottom of the file, we're going to define a new custom object type using the type keyword, and then we're going to give this a name. I'm going to call this post subscription payload. So subscription payload is a common suffix for what we're doing here, the payload that we're defining that comes back from a post. And then the initial word is just the actual subscription name. So right here, the subscription is post, so we start with post. Then it is actually the subscription payload, so we add subscription payload afterwards. This is a common naming convention you'll see used throughout the GraphQL ecosystem. Now, what exactly is coming back from the post subscription payload? Well, we're going to get two things. One is going to be our new field mutation, which is going to be a non-nullable string. So you're always going to get a string back that describes what type of mutation actually triggered this event. The other thing you're going to get is the actual data. So in this case, the data under the data field would just be the post, exactly like we already have. So now we have our new post subscription payload type, and we can actually use that as opposed to the one we're currently using. Up above, I'm going to remove post and replace it with post subscription payload, and this will also be a non-nullable field. So you will never get notified about an event if the post subscription payload is not actually provided. Perfect. So this is all we have to change inside of schema.graphql. We can actually save this file, and we actually don't need to make any changes to subscription.js. This subscribe method is still perfect. It's exactly what we want. All of the additional changes need to happen over in mutation.js, starting with the one pub/sub publish call that we already have that is publishing to the post channel. This needs to be altered to reflect the new structure that we just set up, where we have the mutation field and the data field. To start, I am going to wipe everything we have in the object so far, and I'm going to break it out onto separate lines since we'll be adding in multiple properties. And here, we do still need that root post property. This time though, instead of being the post data, it now is an object that matches up with the type we just created. So this is an object that needs those two fields. It needs mutation with a string value, and it needs data that contains our post object. So let's set both up right here. We're going to start off with mutation, setting it equal to a string, and I'm going to be using uppercase letters for this, either uppercase created, uppercase updated, or uppercase deleted. In this case, it is a created based mutation. Next up is our data. So we have that data property set equal to, and in this case, all of the post data lives on that post variable. So we reference the post variable like so. Perfect. Now, if you're wondering why this is uppercase, it's just a common convention for some constants like this. It would be just fine to use lowercase or to call it whatever you want. This is merely a stylistic choice. It is not enforced in any way whatsoever by GraphQL or the pub/sub mechanism. Now that we have this in place, we can actually save mutation.js and test things out so far. I should be able to subscribe to posts, create a new one, and see our new structure showing up. Over in GraphQL Playground, I am going to switch over to that post tab, and we are going to need to make a few small changes to the structure. Remember, post is no longer sending back the post data, which is what we're currently selecting. Post instead is sending back that object with the mutation and with the data fields. We're going to grab both. We're going to grab mutation so we know what kind of mutation triggered that event. And we're also going to grab data, and from there, we will provide a selection set asking for some information about, in this case, the post. I'm going to ask for the ID, I'll ask for the title, for the body, and some info about the author. I'll ask for the author's ID and the author's name so I can display those as well. Now we're going to be able to first refresh that schema to see that our current operation is valid. I'm then going to run the subscription. We can see down below that it's listening. And the last thing we have to do is create a new post. I'm going to scroll over to that Create Post tab. We can run the Create Post mutation exactly as we have it, since it is creating a post with published set to true. Once it's created, we can go back over to the Post Subscription tab, and right here I do indeed see my object. We now have the data property and the post property, which we had before. This time, though, we are getting the mutation type, so we can see that this event fired because some data was created, in this case, the comment data shown below. So now we have successfully set up the created mutation status for that one we already had in place for the one in Create Post. Next up, let's go ahead and knock out Delete Post. So when a post gets deleted, we also want to respond accordingly. Now, this is where things get a little bit tricky. When we're deleting a post, we don't always want to alert subscribers because the post might be a draft post. So if I'm writing a draft for a post and I decide to delete it because the story I shared is a bit embarrassing, I don't want to send that embarrassing story out to all subscribers when I didn't even publish it in the first place. So it's important that we add that conditional check in. I'm going to start by destructuring pub/sub right here. Then down below, after the comment actually gets removed, we're going to check if it was published. So if, and in the if condition, we're going to look at that deleted posts published property. So we look at the deleted posts array, we grab that first and only item, then we access its published property. If that's true, this code is going to run, and in that case, it is safe to run pub/sub.publish to alert people that the post has been deleted. So right here, we do need to provide the two arguments necessary. First, our channel name post, and second, the correct data. This time we have that root post property. We're going to have a mutation value equal to the string deleted. And then we're going to have that data property equal to the deleted post itself, which once again is in the deleted posts array. Accessing that first item, perfect. Now in this case, you'll notice that in a few places, we are grabbing that first item off of deleted posts. We can actually use array destructuring to make that code just a tad bit cleaner. Just like destructuring an object, what I'm going to do right here is remove the word deleted posts. I'm going to replace it with opening and closing square brackets. Now I can choose names for the array elements. I could call the first one A, the second one B, and the third one C. In this case, though, we know we only have one array item. I am going to call that one the post. So right here, we have the post that is indeed getting deleted. Now that's just going to make the rest of our code a lot easier to work with. Down below, I can just check if post.published. Then down below, right here, where I provide the data, I can just reference that post variable. And finally, where I return the post, I can just return the post instead of needing to access that deleted posts array. Perfect. So now we are successfully alerting people when the post gets deleted. What I'm going to do is save the mutation and actually test this out before moving on to update post. Over inside of GraphQL Playground, once again, I am going to start up our post subscription. We can see that it is listening, and I am going to delete one of the two published posts I have, one with the ID of 10 and the other one with the ID of 12. Right here, I'm already deleting the one with the ID of 12. This is perfect. I can go ahead and run that request. Then I can move back to the post subscription tab, and right here, I can see my notification, this time clearly letting me know I'm getting this data back because the post has been deleted. Now, if I were to delete a post like post 11, which is not published, I would not expect a notification to be sent out. I'm going to remove it, head back to the post tab, and I can see nothing new is showing up, which is fantastic. Now that we're done with the delete post method, let's move on to the last and quite honestly the most confusing of the three, update post. Remember, updating a post might not just be updating a post. If I publish a post using update post, I want to send out that created event. If I unpublish a post using update post, I want to send out that deleted event. And finally, if I just change something like the title and the body for a published post, I actually do indeed want to send out the updated event. That means in reality, update post could be firing out all three different types of mutation events. Now, for the moment, that is going to require us to use a little bit of additional code, and it's not going to be the prettiest code in the world, but don't worry, because in the next section, we're going to be spending our time vastly reducing the amount of code that we actually need to write in these resolver methods. So let's go ahead and kick things off by adding a if statement down below inside of the if statement we already have. So this if statement only runs if the user provided the published status. That's going to allow us to determine if a post is becoming published, in which case it's being created, or if it's becoming unpublished, in which case it's actually being deleted. Now, in order to set up the if statement, we need to know what the post's published value was before it was changed. And to do that, we're going to create a new variable up above, const original post. Original post is just going to be a clone of post at this point in time, before any changes have been made. To clone post, I am just going to use the object spread operator, creating a new object and spreading out all of the fields from post. Perfect. Now we have original post and we can actually use it down below. So let's start setting up a little bit of conditional logic. Right here, if, and we're going to use the following condition. We're going to check if the post was published, but is now unpublished. So is original post dot published equal to true, and using the logical and operator, is the new post published value false? So we're going to use the not operator, then right here, post dot published. Perfect. So was the post originally published and now it's not published? If so, we're going to run some code, and this is where we will actually fire the deleted event. We'll actually fire that off in a few moments. For now, let's just continue setting up our conditional logic. We're going to add an else if onto here. This time around, we're going to see if it was originally not published and now it is published, in which case it's actually being created. So right here, we are going to flip using the logical not operator, original post, dot published. So was it originally not published? And then we're going to make sure it is now published. And if that is the case, right here, we will fire the created event. Now, the last type of update we could have is if it's actually just being updated and the published value isn't being changed. So right here, we can just add else if onto our original if statement, this one right here. And all we're going to do is look at post dot published. Is the post published? If it is published, but they did not already modify the published value, then we know we can safely fire off that updated event. Perfect. So hopefully all of this conditional logic makes sense. If this does not make sense, I recommend not continuing on with the video and heading into the Q&A to look at existing questions on this topic or to ask your own. It's important that it makes sense why all three events can actually be fired from the update post mutation. Now that we have the basic structure in place, all we have to do is use pubsub.publish a couple of times. Right here, I am going to destructure that alongside of db, grabbing pubsub, and then we're going to start using it down below. I'm going to start with the deleted event. Right here, that is going to be pubsub.publish. We are going to publish to the post channel, and then we're going to set up that object. So we need our post property. We need the mutation property on that object. I'll be using deleted, which we've used before. And then we need to set up data with the post data. Now, in the case of a post being deleted, I'm actually not going to use post, which contains the new data, because someone might have updated the title and body while they were unpublishing the post, all in the same operation, and I wouldn't want them to accidentally leak that data when they might not have thought that's how it worked. So what I'm going to do is publish the old data. Right here, all I'm going to do is publish original post, so you can get back the deleted data without any of the changes that were actually made from this particular operation. Awesome. So now we can remove that comment and we can move on to the next one. The next one is the created event. So right here, it is like the post is being created because it is going from unpublished to published. We're going to use pubsub.publish to publish some new data. And in this case, we are still using the same name, the same channel name post, and we still have to set up that object with the post property. That object is going to have mutation with the value of created, and we are also going to set data equal to, and in this case, we are indeed going to publish the latest data since this post has just been made public and the data is available anyways. Right here, referencing post. Excellent. Last up, we have updated, and then we can test things out and we'll be all done for this video. I'm going to use pubsub.publish. We're publishing to post. We're setting up that object with the post property. On that object, we have our mutation property with the value of updated. And we also have our data property. Once again, I will use post with the latest changes since we know this is indeed a published post and the users just changed something like the title or the body. Whoops, that should be the post channel, not POS. Perfect. Now we can actually test things out. To do this, all we have to do is run our post subscription exactly as we already had it. And then what we're going to do is use update post to update posts in various ways, making sure that all three of these fire. So to start, I'm going to use the update post mutation on post 11. If you remember, post 11 is the post that is not published. And I'm going to take it from being unpublished to published. So right here, I'm going to update post 11, setting published equal to true. Now, when I do this, the post is going from being a draft to being a published post, so I should see the created mutation value over in the subscription. I'm going to fire this off, head over to my subscription tab, and right here, I do indeed see created. If I update the post to unpublish it, I should see deleted. Right here, I'm going to unpublish it. I'm going to fire things off, head over to the post subscription tab, and I do indeed see that deleted mutation value. Last up, let's go ahead and just truly update an already published post. I'm going to update post 10. That one is already published, and I'm just going to change its body. So right here, I'll set body equal to the string something new, ... If I actually fire that off, we can see that it did indeed change the post. And if I go over to the post subscription tab, you can see that updated fired. So now someone using the post subscription can actually keep the user interface completely up to date, showing the latest posts with all of the changes and removing posts as they get unpublished or deleted. That's all we're going to do for the post subscription. What you're going to end up doing in the next video is something similar for the comment subscription, though with the comment subscription, we do not have this many conditions to take into account. The conditional logic is a lot simpler, and that's going to make the process much easier. All right, I know this one ran a little long, but I wanted to make sure to put all of this in a single video to prevent any confusion about what's what. That is it for this one. I will see you in the next one, which is a challenge video.